Hi, this is Dr. S and this is video 3 of reaction rates for Year 12 chemistry. In this video we'll look at the factors that are affecting the reaction rates. We'll look at 3 different factors. There are more, but they will come in different videos because they're a bit more detailed. In this video we'll concentrate on surface area, concentration and pressure. And we'll look at how a change in those 3 factors affect the reaction rate. So we'll start with surface area. So for surface area, you might remember at GCSE calculating the surface area of a cube. It's useful to model particles as cubes because it makes the calculations easier. But if you imagine you have a cube like this, you can calculate the surface area. But let's say it's a 2 centimetre cubed. So 2 by 2 by 2. Then you should see that the total surface area there, what we could do is we can calculate the surface area of one of the faces. So 2 times 2 is 4 centimetre cubed, squared, sorry, for a face, and then times that by 6 to find 24 centimetres cubed as the total surface area of that cube. Now imagine we cut that cube down into 8. So imagine I take that face there and I cut it like that. You should be able to see that this cube is being cut into 8 different cubes. I don't need to draw 8 different cubes, but you get the idea. They are now 1 centimetre cubed. So if I calculate the surface area of one of the cubes, each face is 1 centimetre squared. We could times that by 6 to get 6 centimetres squared surface area for 1 cube. But of course there are 8 cubes now. I've split this into 8. So if I times that by 8, I now get 48 centimetres cubed total surface area. So it's exactly the same mass of substance. I've just cut it into smaller pieces and I've doubled the surface area. So smaller pieces, so a powder maybe rather than chunks, has a larger surface area. Now if you imagine what we said about collision theory, in order for something to come in and react with this material, it would have to collide with the particles. It can only collide on the surface, so the more surface area there is, the more space there is for particles to actually hit each other. Okay? So your explanation for surface area is that there are more particles on the surface. So more frequent collisions. Remember, we're talking about rate of reaction, so we have to have some relation to time. So that's why we say more frequent. We don't just say more collisions, we say more frequent collisions. If there's more frequent collisions, the reaction rate increases. Okay, and that is with a higher surface area, which remember is the smaller particles. Presuming there's the same amount of mass, the smaller particles have the higher surface area. That's commonly mixed up. Okay, now the other 2, concentration and pressure. Now, concentration and pressure can be sort of thought of in the same way. Concentration refers to liquids, pressure refers to gases. But in both cases, what they are a measure of the number of particles in a volume. So we call it the number of particles per unit volume. Okay? So for concentration, we know that that's a decimetre cubed. So imagine we have some particles in a box. You should be able to see that the right hand box has more particles in it, simple as that. So this has a higher concentration. That's if it's liquid particles. Imagine that that is then a solution and these are the solute particles. There's a higher concentration. If this is a gas, these are the gas particles. You can see that there's more gas particles here, so there would be a higher pressure. So concentration and pressure can be explained in the same way. Again, thinking about collision theory, it should be hopefully quite obvious that the particles here are more likely to hit each other than here. They're all moving about randomly. The likelihood of two particles colliding is going to be higher if there are more particles there. So this explains why a higher concentration or a higher pressure lead to a higher reaction rate. So your explanation is the same either way. So I'll do it for concentration, but the explanation for pressure is just the same. Increased concentration means that there are more particles per unit volume. So that leads to more frequent, collisions. Again, there's got to be some relation to time, more frequent collisions. So that leads to an increased reaction rate. So hopefully that explains how a change in surface area or a change in concentration or pressure can change the reaction rate. There are two more factors that we'll come across in the future. They are temperature or the presence of a catalyst, but they are, as I said earlier, more detailed explanations, so require a video of their own. Okay, next time we'll look at how to actually measure a reaction rate in an experiment. Okay, I'll see you then.